The multi-location type identifies any single location that exists within the world of consensus. It is quite an abstract idea and can represent all manner of things that exist within consensus, from a scalable multi-shard blockchain such as Polkadot all the way down to a lowly 20-asset account on a parachain. In computer science terms, it's really just a global singleton data structure, regardless of its size or complexity. Multi-location always expresses our location relative to the current location. You can think of it a bit like a file system path, but where there is no way of directly expressing the root of the file system tree. This is for a simple reason. In the world of Polkadot, blockchains can be merged into, and split from, other blockchains. A blockchain can begin life very much alone, and eventually be elevated to become a parachain within a larger consensus. If it did that, then the meaning of root would change overnight, and this could spell chaos for XCM messages and anything else using multi-location. To keep things simple, we excluded this possibility altogether. Locations in XCM are hierarchical. Some places in consensus are wholly encapsulated within other places in consensus. A parachain of Polkadot exists wholly within the overall Polkadot consensus, and we call it an interior location. Putting it more strictly, we can say that whenever there is a consensus system, any change in which implies a change in another consensus system, then the former system is interior to the latter. For example, a Canvas smart contract is interior to the contracts palette which hosts it, and UTXO in Bitcoin is interior to the Bitcoin blockchain. This means that XCM doesn't distinguish between the two questions who and where. From the point of view of something fairly abstract like XCM, the difference isn't really important. The two blur and become essentially the same thing. Multi-locations are used to identify places to send XCM messages, places which can receive assets and then can even help describe the type of an asset itself, as we will see. Very useful things. When written down in text like this article, they are expressed as some number of or parent, the encapsulating consensus system, components followed by some number of junctions, all separated by comma. This isn't what generally happens when we express them in a language like Rust, but it makes sense in writing since it's quite a lot like the familiar directory paths that are in widespread use. Junctions identify an interior location within its encapsulating consensus system. If there are no parent junctions at all, then we just say that the location is here. Some examples: parachain 1000, evaluated within a parachain. This would identify our sibling parachain of index 1000. In Rust we would write parent then, parachain 1000 into, account ID 32, 0 times 1234, def, evaluated within a parachain. This would identify the 32-byte account 0 times 1234, def on the relay chain. Parachain 42, account key 20, 0 times 1234, apt, evaluated on a relay chain. This would identify the 20-byte account 0 times 1234, apt on parachain number 42, presumably something like Moonbeam which hosts Ethereum-compatible accounts. There are many different types of junction for identifying places you might find on-chain in all sorts of ways, such as keys, indices, binary blobs and plurality descriptions. When working in XCM, it's often needed to refer to an asset of some sort. This is because practically all public blockchains in existence rely on some native digital asset to provide the backbone for its internal economy and security mechanism. For proof-of-work blockchains such as Bitcoin, the native asset, BTC, is used to reward the miners who grow the blockchain and prevent double spending. For proof-of-stake blockchains such as Polkadot, the native asset, DOT, is used as a form of collateral, where network keepers, known as stakers, must risk it in order to generate valid blocks and be rewarded in kind. Some blockchains manage multiple assets. For example, Ethereum's ERC20 framework allows for many different assets to be managed on-chain. Some manage assets which are not fungible, such as Ethereum's ETH, rather are non-fungible, one-of-a-kind instances. CryptoKitties was an early example of such non-fungible tokens or NFTs. XCM is designed to be able to handle all such assets without breaking a sweat. For this purpose, there is the data type multi-asset together with its associated types multi-assets, wild multi-asset and multi-asset filter. Let's look at multi-asset in Rust. So there's two fields which define our asset, id and fun. This is pretty indicative of how XCM approaches assets. Firstly, an overall asset identity must be provided. For fungible assets, this simply identifies the asset. For NFTs, this identifies the overall asset class. Different asset instances may within this class. The asset identity is expressed in one of two ways, either concrete or abstract. Abstract is not really in use, but it allows asset IDs to be specified by name. This is convenient, but relies on the receiver interpreting the name in the way that the sender expects, which may not always be so easy. Concrete is in general usage and uses our location to identify an asset unambiguously. For native assets, such as DOT, the asset tends to be identified as the chain which mints the asset, the Polkadot relay chain in this case, which would be the location from one its parachains. Assets that are primarily administered within a chain's palette may be identified by a location including their index within that palette. For example, the Kerala parachain might refer to an asset on the Statamine parachain with the location, parachain, 1000, palette instance, 50, general index, 42.